Alright, so for this video I'm going to be doing a recording, guys. If you need to stop at any time, make sure you pause it. Rewind it if you need to look over something that I did again, or just kind of take a second look at it, that's fine. But this should be a little bit shorter today. You will have an assignment after these notes are done. These are just like the guided notes in eBackpack, so go ahead and open those up. Since I'm going to be gone today, I figured we can go ahead and cover this lesson. It's not that complicated, but it will take some time to figure out. When we look at this, it says the graph of an equation in two variables is a set of points in a coordinate plane that represent all the solutions of an equation. So points is what is going to go in that fill in the blank. An equation whose graph is a line is called a linear equation, and that's what we're going to start talking about this chapter. Linear equations. Example 3, graph the equation, tell whether the equation is a function. Well, we already know how to tell if it's a function or not. When it's on a coordinate plane, we do the vertical line test. The only other thing that we have to do here, and you have to do this on every problem, is make a table. We will learn a shorter way here before the chapter is over, but for these first ones, we're going to make a table. And what we're going to do is we're going to select some values for x to plug in. So I'm going to say my x values are going to be -2, -1, 0, 1, and 2. You should start every single problem today with this table when it says to graph. Exactly like this. Once you have this table, then you can begin your problem. The table actually makes this pretty simple. We're going to take our equation and we're going to plug in those values for x and solve for y. So my first value for x is -2. So if I plug -2 in, it's going to be -4 minus 1, and my value for y becomes -5. So I just go up here and I put it in the table. Okay, and we're going to continue this process all the way through. So I'm going to erase these and I'm going to put a new value in there for x. The next value is -1. 2 times -1 is -2 minus 1. That gives me -3. Continuing the process should be pretty easy for 0. We have 2 times 0, which is 0 minus 1. That gives me -1. Next one is 1 that we're going to plug into the table. So I say 2 times 1 is 2, minus 1 is going to give me +1. And the last value that I'm going to plug into the table is going to be 2. 2 times 2 is 4, minus 1 gives us 3. Now we have a table, and we've already graphed things from a table. We know that we can write all of these things in this table as points in a coordinate plane. So what we're going to do is we're just going to take those table values and change them into coordinate points. So for the first table value, -2, -5, I'm going to go left 2, and I'm going to go down 5. So left 2, down 5 on the coordinate plane, and that's where my point should be, right there. The next value, left 1, down 3, right here. The next value, 0, -1 right here, 1, 1, and 2, 3. This should produce a line. Again, if we do our vertical line test anywhere through this, we can tell that it will not hit any 2 points. So we will say that yes, this is a function once we are done. So yes, it's a function. Go ahead and take a second to do the second one. Pause the video and take an opportunity to try it yourself. I'll put the answer on here so that you can check and make sure you're right, but if you need assistance on how to do the problem, you'll look back to example A. I will take a short second here to tell you again, this is what you start with, and then you start plugging values in. Okay, after you have this table, then you can start your problem and plugging in all those values. So once you finish your problem, here's what your output values would be, and your graph is on the right there. You can see that it does still pass the vertical line test, so we put yes, it is a function. Other than that, you guys, this is pretty straightforward. If you look at all these coordinate points, they match up with the values in the table right here. So we'll move on to the next page. Example C should be pretty easy. The one thing I will show you on this very first one is that when we plug into the function y equals negative and then we plug our value in plus 3, we have to watch for those double negative signs for the first couple values. So that double negative makes this 2 plus 3, which gives us 5 for an output. Go ahead and pause and try the next 4 values on your own in graphing, and before you move on to D, I will show you something different that we're going to do because we have a fraction. So here are our answers for C. If you look, this is what you would get for all of your outputs, 5, 4, 3, 2, 1. Again, it is a function, so you can put yes. You can put yes next to this one also. Any linear function, scratch that, almost every linear function will be considered a function because it will pass the vertical line test. Now, moving on to example D, if you look at this here, we're going to do something a little bit different. Like I said, I'll show you how to set the table up, and the only reason we're going to change our values of x is because of our fraction. Since we have a fraction value, what we're going to do is instead of saying -2, -1, and so on, what we're going to do is we're going to take all of these old table values and we're going to put some new table values that are going to make this problem a little bit easier for us. Again, what we're going to do is continue to write these values 0, 1, 2, and so on. And now what we're going to do is instead of writing this y column, what I'm going to do is I'm going to make another x column and I'm going to change my values of x so that this is easier to graph. When we have a fraction in front of x, what we're going to do is we're going to multiply that number by whatever the denominator is. So my x value is -2. Excuse me, my x value is -2, so I'm going to multiply -2 by the denominator, which is 2, and that will give me -4. -1 times 2 is -2. 0 times 2 is still 0. 1 times 2 and 2 times 2. Okay, now these are all values of x, not y. Now what we're going to do is we're going to find our values of y by plugging in the blue x's, not the black ones. So we have y equals 1/2, and we're going to plug in a value plus 1. I'll show you how easy it is on this first one, and after that I'll let you guys plug in the rest because you'll have to do some on your homework. So what we're going to do is we're going to plug in -4, and when you guys do fractions, remember that we multiply straight across. So this is what it looks like, and when we do that, it's going to cross cancel because we chose to do multiples of 2. So this new value is -2. It'll cross cancel on every single one with that denominator, so really all I have left to do is -2 plus 1, and my output is -1. Now, you could go through this and just leave your values the same up here, but what will happen is you'll get a bunch of decimals. On this, we won't get any decimals. So go through this, see if you get any decimals, and then plot all your points, and I'll go over the answer with you when you're finished. The one thing to keep in mind when you guys are graphing this, now that we've changed our values of x, we need to remember that when we do this for our first point, we have to go to -4 and down 1, not -2 and down 1. The next point we got was -2, 0 if you did it correctly, so -2 and then up and down 0. Then 0, 1 was a point, and then 2, 2 was our next point, and then 4, 3 was our next point. Now again, this makes it a lot easier when you multiply our x's by whatever your denominator happens to be. And this gave us nice whole answers. So if your denominator happened to be 5, you can multiply all your x's by 5, and you will end up canceling out that denominator just like we did here and getting a nice whole number answer. We'll move on to the next page now. Alright, so we have a couple special cases here. If you look up at the top of this page, anytime we have y equals a number, it's going to produce a horizontal line. And again, horizontal lines go like this. Okay, so anytime it says just y equals a number, it's a horizontal line. On the other hand, if it says x equals a number, it's going to be a vertical line, which again, vertical is like this. So the next two graphs are going to be super easy. You don't have to worry about a table here because there's no table to make. Anywhere where the value of y is equal to 3, well, we know y is equal to 3 right here, and everywhere else where y is equal to 3 will be along this horizontal line. And that's your answer. You don't need to make a table for these. These are the easiest ones on your homework. Likewise, if you try example B, so pause it, try example B, but it should take you no time at all. If we look, where does x equal -2? Well, we start at 0 and we go left 2 and we plot our point. Again, x produces a vertical line, so that's where x is equal to -2. A common mistake students make is that they'll go to y equals 3 and then they'll draw a line like this. Well, that's not y equals 3 everywhere, because if you look at where my dot is hitting this number line, all of these values are y. So we have to make sure we go this way, because everywhere that way is y equal to 3. We'll go ahead and move on to the last page of notes now. Okay, this last page is something that we'll have to practice a lot because we just have a hard time picking up on it sometimes. An equation that has y alone on the left side of an equal sign is in function form. We also call this slope-intercept form when we learned about it next year in algebra. But if you look at it right here, this is one and the same equation. What we want to do on every single one of our problems to make our lives easier is to isolate the y value. So what you can do here to move this entire term, we want to move 3x. In order to move that 3x, we have to subtract it to the other side. And you cannot combine 7 and -3x. So what we do is we write the 3x term first. We have our y alone on the left-hand side now, and we write our 3x term first and then our positive 7 second. And that is exactly what they have in function form right here. Now what we would do is we would make our table and graph this function until we learn about slope-intercept form. I'll help you out with this first one. We'll have to practice this quite a bit. Again, understand that it doesn't come to everybody right away. This first one is a good one because you're going to end up getting a fraction in front of x, and that's okay. But the first step to isolating x in this one, isolating y, is to subtract x to the other side. That's going to cancel it on this side. What we'll have left is 2y equals -x plus 6. We have to isolate y all the way. Notice that y is not by itself, it has a 2 with it. So in the next step, what we have to do is we have to divide by 2. Well, when we do it to one side of the equal sign, we have to do it everywhere. Students sometimes have a problem with this. They can see that the 2's cancel on the left-hand side, but what we need to understand is that there's really a 1 in front of this x. So what we're going to write, if there's no number in front of x, what we're just going to write is 1. This 1 happens to be negative. We're going to write 1/2 x plus 3. Okay? Now what I want you to do is go ahead and make that table and use the table that we used in example D on page 2 of the notes, and you'll get whole number answers here. I'll write the table out, but you guys try it and then see how you did. Alright, so if we made the table, here are the values that you would get. Again, we don't want our x's to be -2 to +2 because we end up with a fraction. You're going to end up with a fraction on this one as well. I'll show you the table that you should use. But other than that, we should be okay with this. Now here's what our graph looks like over here. Notice that it's going down, but we see all of these coordinate points should match up with all the points in our graph. And it is a function because it's a linear function. Before I try this again, I strongly encourage you to practice isolating y. So go ahead and pause this and try to isolate y by yourself. Once you've tried, see what you get. Again, avoid getting decimals. We don't want to graph using decimals ever. We want to use fractions, even though they're not that easy to work with either. But once we learn about slope-intercept form, it will make our lives a lot easier. Take a couple seconds, pause the video. I'm going to go ahead right now and isolate y. So our first step, since this 2x is positive, is we have to subtract the 2x to the other side. Now what that leaves us with on the left-hand side is -3y is equal to, again, we always like to put the x value first. So we're going to put the -2x, and then the 3 is positive, so I'm going to put plus 3. Okay, and again, that's this 3 right here. Now, again, our y is still not isolated, so our next step would be to divide off that -3. When we do it there, we have to go everywhere through the equation and divide by -3. It's going to cancel the -3's in front of the y, and here's what we get. Y equals, again, we look at our function. We don't want to change this to 0.6 repeating. Let's just leave it a fraction, but we have a negative over a negative, and we should all know that that's +2/3, and we put our x, and then 3 divided by -3 is -1. So here's our function. Now, take a second and see if you can't figure out what the value should be in this table. Alright, so now we're going to look at this. Instead of negative 2, we're going to take it times 3 and get negative 6, negative 3, 0, 3, and 6. If you didn't do this, you would get answers in your table, but they would all be decimal answers. I know that when I plug all these values in, I won't get decimals. So go ahead and take a second, plug those values in, and try and graph this last one. Alright, so here are our values that you get. Again, we look at our coordinate points after this. Negative 6, 5 should match up. And again, we look all the way through here, but this is what we get for our line if we did this correctly. Again, if you're confused on this, just take a couple minutes, go back through the video. When you're working your homework, try and find a problem. You can fast forward through the video to find exactly where you have an example of one like you're working on and see if you can't figure it out. Understand we'll have to spend multiple days on this, so don't get too frustrated, but this video should help.